So in the previous video, I introduced you to the idea that our focus this year in advanced algebra is to study these things we call functions, and to do these four things: graph them, transform them, solve their related equations, and solve their related word problems. So what is the first function family that we're going to study this year? And the answer to that is quadratics. Within the next few days, we're building towards these things we call quadratics. And here we go. Not surprisingly, what are we going to do with these quadratics? These four ideas. So I'll refer back to this constantly over the course of the year. It's quite possible that many of you studied quadratics in your previous algebra class, your Algebra 1 class, but for some of you that's been some time. So I think, in all fairness, it's important to reactivate some prior knowledge. And I think perhaps an important term, a really critical term to know as we get ready to talk about functions, what kind of functions, in particular quadratic functions, a term that we have to be really familiar with as far as vocabulary is concerned is the term relations. You'll notice that I don't have a textbook definition for relations here. I may discuss one with you, but first I want you to take a look at this relation. This is an example of a relation. This is example A. And it looks pretty benign. It looks pretty innocuous. You've probably seen this at some point in your math career. And I want you to kind of compare and juxtapose that with this example of a relation. So this collection here would be referred to as a relation, as would this collection here. And what I would encourage you to do is maybe pause the video for a few minutes and take a look at these two examples and ask yourself, and this is a practice that we'll employ a lot in our classroom, what if the teacher doesn't provide a definition? What do I notice about what he's provided? What am I wondering? And if I were to have to come up with my own definition of a relation, just based on what's in front of me here, using a little bit of intuition and perhaps some common sense, what would I guess a relation to be? So if you did take some time to do that, I hope you came up with this idea that it looks like a relation is just a collection of ordered pairs. You know, we would refer to 4, 10 as an ordered pair. Same thing with -6, 5. So the relation is a collection of these ordered pairs. In this case, there happen to be 4 ordered pairs in this relation. And in this example, there happen to be 5 ordered pairs. And one of the relations really has no story. It's just a set of ordered pairs. It's just, if we were to graph this, 4 dots in space. And here there seems to be this really kind of rich story surrounding this relation. In particular, this relation seems to be describing the average gestation for mammalian quadrupeds. What are we talking about? These are mammals that walk on all fours, and we are graphing, or actually, excuse me, we are describing their weight in kilograms, and we're comparing that to their gestation in days. And that's just a word meaning the length of pregnancy from conception to delivery. And you could kind of just dismiss this and say, well, this looks like a random collection of numbers, but there's actually a beautiful story being told here about the size of a mammalian quadruped versus its gestational period. So the African elephant's average weight in kilograms, the female is about 5,000 kilograms, and she has a gestational period of 640 days. So compare that to a human's gestational period of 9 months. So this is in excess of a year that a female elephant carries that baby to term. And contrast that, for instance, with something as small as a rabbit that weighs about a kilogram and has a gestational period of only about a month, 33 days. So relations can tell stories, and they can really inform us, and sometimes they're just kind of bare. It's just a collection of ordered pairs, but both of these are considered relations. I do want to make a quick note about how important mathematical notation is. It's critical. You'll notice that in reporting these relations, in both cases, I start out with a brace, and there's a brace at the end to match with that initial brace. And of course, these ordered pairs, each of them is contained in a set of parentheses with commas separating each ordered pair. How important is notation? Is it something that you should be paying attention to? Well, let me give you an example to consider that comes from English. And take a look at the following sentence, which reads, a woman without her man is nothing. I hope that you find the sentence offensive. It is offensive. It's sexist. It's essentially saying that a woman that doesn't have a man isn't worth much. And I would expect you to not be so pleased with this sentence. If we add some punctuation to this sentence, it's equally offensive, but it says something very, very different. It's read, a woman, without her, man is nothing. Both statements are pretty horrendous. Both of them are sexist, and I don't agree with either statement. I use the two sentences to illustrate how critical, how important notation is in math. So it is critical that when reporting a relation or any mathematical idea, you really pay close attention to your notation. I'll be back in the next video to continue.